Hello, hello, hello. Cheers, Kevin here, and welcome back to some more While True Learn. We are working on a task for President Crump, or actually, maybe we should look at startup. Nah, we're gonna do a task for President. Well, how are our current startups doing? Oh, good. We're making money. We're making money with all of these, with both of our companies. That's nice. $740 of income. That's pretty sweet. Yeah, nice. I like it. If we go to mail, yeah, there are new startups that are interested in us. I don't know. Sure, let's take a look at these. How hard could they possibly be? Oh, not enough money. Okay, fair enough. What about this one? Not enough money. We don't have enough money to be investing in these startups. Shame on us. Okay, well, it's time to take jobs. Predict presidential elections. So I need to know who to vote for. Can you predict the winner of the next presidential elections? I will send you a big database. All right, from President Crump. Let's see. Oh, okay. This is a big database, and we need to just only show blue. All right, fair enough. We know how to do that. We need 300 blues, and it needs to be 80% accurate. Oh, interesting. I wonder what's going to happen here. That 80% accurate is interesting. Blue, green will go to the trash. Blue, red will go to the trash. So I have trash. Here's some trash. Is this going to be too slow? It'll probably be too slow. That's probably why we have this whole 80% accuracy thing here. Get stuff through. Yeah, that's going to be crazy slow. Oof. $1,700. So probably we get to parallelize a little bit, but not much. Man, okay, so we only got 60 out of the 300, so we would need five times this. Yuck. We do have a random forest, but that's slower. Well, actually, it's not slower if we include the transfer time of these. So if we were to do just RGB here, red, green, blue, send the blue along, send everything else to the trash. The fact that these icons are different is a little confusing to me. Oops. Yeah, no, that's right. I think in total, this would probably be faster. But why is it thrown? Okay. Yeah, it's just that it's slow. All right, whatever. Oh, that only got 15 out. Okay, never mind. I guess the transfer time. I'm confused about what transfer time means then. Well, whatever. Okay, so we only get these decision trees in random forests. We have only red fast, RGB quick sort. I mean, that's hecka fast. Let's try that. Red, green, blue. Is that going to be fast enough? I'm guessing not. I mean, it's a lot faster, but we are paying for extra servers that way. We can send some bad data up here though. Because we only need the accuracy to be 80%. So what if, since all the stuff that's going to the trash is garbage anyway, what if we send some of the garbage into here just to get our quota, right? I don't know, red and so this stuff is all just going to be red and green. So half of that we'll send back into there. Well, actually, we don't even need a decision tree to do that. Let's send red to there and we'll say, hey, green and blues are now going to be blues. And let's see how bad that tanks our accuracy. It's going to tank it. Well, that should get us, what, 66% accurate, right? So we only need to filter out a tiny little bit. Yeah, okay, accuracy was 78%. We only need to filter out some to make this a little bit better. Okay, so red will go straight to the trash, but green will say, hey, green and green, or any and any, we don't care. We're just using this to filter some stuff out. So half of that will go to the trash again. The rest of it, though, can go ahead and mosey on through. We'll just send some bad data down the line, and I don't think we're quite fast enough. Not quite fast enough, no. But our accuracy is fine. Huh. I'm wondering, so let's do the same thing with red. I think this is gonna, this is really dumb. But I mean, maybe this is a valid strategy. I mean, we're sending data we know is bad. Oh, there's not much red data anyway. Okay, never mind. Yeah, so that's not gonna help at all. Oh, actually, maybe that will help because we can just send red straight on in because it's only 6 pieces of data. Oh, no. Okay. Actually, wait a second. 300 pieces of data means that we need to get 80% of that. So 80 plus that's 160. We only need 240 pieces of blue data to show up, and everything else can be garbage. So what, do we get 240 pieces of blue data into here in the time limit? Because if so, then yeah, we can just fill it with junk. No, we don't end up in that. Okay. So we don't get enough good data anyway. Okay, so we do need to use a load balancer then. Or somehow make this faster. No, I'm confused. Well, whatever. Let's build our own thing here. We need an RGB sort. No, the RGB. We can use our slow RGB sort. It's weird because we lose some of the benefit of using RGB quicksort is nice, but then we're paying for the service and we don't get to use the two chains, so we don't get to have a happy fun time. Okay, let's send the blues in and see if we get 240. No, we need to route everything else to trash for now. If we get to 240, then we can just throw extra junk and just try and reduce the amount of junk that gets through until we get to a happy number. But this does not seem like it's doing better. Why is this not doing better? All right. I guess four parallel. 4 parallel, and then RGB sort that. I mean, we could, if we get all of the blue data and we just do this accurately, then we're golden. So, I mean, that works. Oops, no, wrong. This. And then we should just be able to copy this and paste it 4 times. Yeah. Okay, I like it. I don't like how this is laid out, but I like this. Whoa, what? Okay, a little bit of a glitch there. But yeah, we're paying some hefty server costs for this strategy that I'm less a fan of. Okay, but let's see. There we go. Oh man, it feels like we're not even gonna get the... Okay, well, we're gonna get, I think, at least to the 260 or whatever we need. 260, yeah, okay, we got to 260, so now we can just get send some of the green in and see if that's enough. It'll be a quarter of the green. Is that gonna give us enough? Our accuracy is gonna dip, but our occupancy will go up. If not, we'll try throwing another, nope, 283, all right, we're getting there. Let's try throwing 2 of them in, and then if we have to back off from that, we can. This accuracy is right on the line. Aha, perfect. Okay, so yeah, just throw junk at it, and then you're fine. We're still paying crazy server costs, though. Yuck. Okay, and we are complete. So that feels weird. Just deliberately throwing in bad data. Yuck. Okay, well, whatever. If we look at, now I'm curious, just looking at, yeah, we're very overloaded with the self-driving car business. We could go through and add more parallelization, but it doesn't seem smart. Weekly income for Gamazon seems great. Let's accept another job and just see what we can do. Okay, ooh, now this is fun. Just circles and just red. Okay, well, that should be easy, right? It ought to be. Just red and then just circles. Now this is the one thing that's nice here is that it's a little bit easier than with the startups. We're trying to figure out, should we decision tree first or should we sift? Is a little bit cleaner. Okay, so we'll use, yeah, so red and green, and then red and blue, and then trash. Oops. And then circle, and then trash, and there we go. This is way too slow. Oh, we only need to get 1 piece of data through here. That's interesting. Oh, wow. We only need to get 1 piece of data through. Oh, but there is only 1 piece of data that we can get through. Okay, so we need to process through we need to get rid of a lot of junk. Interesting. What sorts of things do we have? Oh, we already have a, no, we already have a, yeah, we need to use our RGB sort. This costs no service, but it gets rid of the transfer time between those two decisions. Yeah, those two decisions. So R goes to here, G and B go to trash. Test. This is at least faster. We're not getting the circle though. Yeah, the circle is not coming out in that amount of time. And I think that's another function of, hey, this thing is going to take 0.27 seconds to process stuff. So let's try our fast RGB sort. That already has a load balancer built into it. RGB quick sort. And then the sifter at the very end. Putting the sifter at the beginning is going to mean that it's just not going to give us out the data. All right, we're getting closer, hopefully. Aha, we got a circle. Perfect. Nice, okay. Now, just to prove the point, if we were to first try and sift out the circle, and then throw that to trash, and then throw that to red, this is going to be a nightmare. Yeah, because now the thing that's interesting to me is that the incoming data, is it just based on how much, because it's not filling up the queue, the socket queue. Is it based on it only releases so much once things are fully processed? I don't know. I don't know what's dictating how fast our input comes out, but let's go ahead and fix this up real quick anyway. Red goes here, this goes here, this goes here, this goes there. Yeah, okay, that's good. Just testing it again once more. This is good and cheap, and that's the way I like it. Okay, cool. Release. And release complete. Next project. Okay. Good morning. Our center helps in the extraction of data from social surveys. We are facing issues and almost reached our deadline. Please write a program that can extract as many information as fast as possible. Please write something self-learning. Ooh, this should be interesting. Let's take a look. Ooh, deep news every day since 1905. World champion versus genetic algorithm. One of the greatest chess games of all time is without a doubt the battle between Garry Kasparov and the Deep Blue. That's Deep Blue supercomputer by IBM in 1997. The first game was very difficult and tense. Kasparov had an advantage at first, but starting from move 44, many believe that he ceased to understand the logic of the computer and in the end lost the entire match. He ended up throwing a fit at one point because he said there's no way that's a computer move. I recall that. Anyway, okay. Ooh. Ooh. Okay, so we've moved on into new fancy pants things. Duplicate. What is duplicate? This node creates several copies of the element. Ooh, one of the steps in genetic algorithm creates clones of a given object. It helps to train the algorithm faster. Nice. Genetic solver. Let's look at this. Train the model in the test run until the evolve button does not light up. Then click on it. It creates a clone with modified error. Okay. One of the most powerful self-learning non-neural algorithms. It simulates biological evolution process. Okay. How does that's interesting. Let's wire this up just in its basic form. Because I've done stuff with genetic algorithms. I'm sort of confused as to what exactly this does. But sure, let's go ahead and train. Are we paying any cost to train? We're not? Yeah, okay. Ooh, it's now saved as, okay, so we can now evolve. This is creating that. So the idea with, okay, let's train these. Okay, now the evolve button is on. Evolve this. Now I'm confused. Evolve this. What? What? In theory, you should be merging. There should be some sort of crossing over of stuff. What? Why is this duplicating stuff? Why are we getting duplicate? I don't know what this is. What is this? Oh, okay, so the error question mark is a little bit... Okay, so this is a little bit confusing. The error question mark is in theory better than the previous version, but we don't see the error until we actually run training data on it. Interesting. Okay, I'm going to take this out entirely just because I want to play with this duplicator real quick. So this should theoretically give us more information. And yeah, we'll have it go ahead and do its sorting. This is a weird way to represent genetic algorithms, I think. Okay, let's train this and see. It should, in theory, get better faster. Sure, evolve. Okay, so it creates a copy and then leaves the old one behind, which is weird. Yeah, okay. So no, it feels like this is just. It's not. Yeah, it's not reducing the error faster. It's just getting to that evolve button faster, which right now isn't particularly helpful. But whatever, sure, that's fine. Training, do. Okay, evolve error %9. I mean, if we can get this error down to nothing, then great, right? Yeah, it ran out of time. Low accuracy. Cool. This. Oh, is it not going to? I don't know. I'm sort of confused. Yeah, no, it's just stuck at 9, it seems. Local optima? I don't know. I mean, I'm just wondering, since we're going to, I guess, hold on to this for later, if there's any benefit to... Well, whatever. Yeah, let's go ahead and launch that. So 9% error, but we're going to get the data in there, so that's good. Complete in 10 seconds. Great. So that's a little interesting. Bigger reward, very little cat cloud time. Chessbot for training Gasparov. As you may know, Gasparov will compete with a computer in chess next month. Can you write a chessbot for training? That sounds like fun. But we have a lot of money to spend, don't we? Let's look at our startups because the startup money, in theory, we can also buy some more tech. But if we're making money on the startups, then we should be in a better position to buy stuff. Okay, our lab is researching cancer cells, and we are close to, let's say, breakthrough in this field of medicine. We are a startup, and we need a qualified specialist in our team who will be able to write an algorithm which will divide cancer cells by type. There are 2 types we found at the moment. Are you ready to serve science? You betcha. Okay. So, no green and no squares. Fair enough. Green, squares. Let's see what custom nodes we get. All green divide, RGB sort, and then it needs to be 100% accurate. Shape divide. This is fast shape divide, but it's using 6 servers. Blech. Only blue 60%. Only red circle. Slow. Okay. Let's see. RGB quicksort plus server costs. Fair enough. Yeah, I think that's what we do. We just do that, and then trash the green, and then 2 sifters to get rid of the squares. So here we do at least get the benefit of the load balancer. Or actually, no, we don't, do we? Oh, I don't know. This is hard. This game is challenging. I'm curious. Let's see what happens here. Yeah, this is creeping up, and we're getting blocked. Okay, so this way we get 2 sifters, but if we were to use RGB regular sort and use our own load balancer, then we get to use 2 RGB regular sorts. Yeah, which means that we get to use 4 sifters, which is going to end up being faster. Yeah, so this is a little bit... Yeah, this is one of those cases where having these custom nodes can be a little bit misleading, I guess, right? If we do this, we're paying the same cost for the extra 2 servers. Green goes to trash, green goes to trash, and then we can have a red sifter and a blue sifter on both of these. And then, yeah, square to trash, this to that, and then that sifter there, sifter there, squares to trash, non-squares to there. Okay, everything is hooked up. Let's test it real quick. Yeah, this certainly seems better to me. We're at least getting... I mean, we're still getting backed up on some of these sifters. We're getting a lot more red. Why are we getting a lot more... Well, no, I take it. It looks that way for whatever reason. But that's fine. All right, that's good enough. Let's go ahead and release that one. All right. We're still making plenty of... Ooh, man, we're making $11,000 a week from Gamazon. That sounds great. Let's look at one more startup because, hey, why not? Let's do that. Startups. Soap making business from Fighters. Interesting. Budget is... Ooh, that's a very high budget. Oh, we don't have enough money. Okay. I'm presuming then we don't have enough money for this. Oh, we do have enough money for this. Hello, we are writing to you from our scientific laboratory. We want to launch a scientific startup. We need a programmer who can write a small part of it, an optimization library which will use the genetic algorithm. Hey, cool, we just started doing that. Let's learn. All right, genetic solver. Ooh, okay. Triangle. Okay, so these, why do we need to use the genetic solver here? Triangles, red, blue, ooh, yuck. Yuck, yuck, yuck. What, why, whoa. Okay, so now I'm curious. If the genetic algorithm is, can we just evolve this in perpetuity? Because is this red really red, or is this just learning what we expect the output to be? So if we train it on what our expectations are, do we get better over time? Does our accuracy get better? I'm guessing not. See now the red, blue, the red, green, and blue are kind of confusing me. 29% error. It's still, yeah, this doesn't seem to be, well, I guess it's hard to even know what it's supposed to be. Okay, I guess let's continue to evolve this over and over and over. Because now is this just color coding for some arbitrary thing? Maybe. It could be. Yeah, this genetic solver does not seem... Ugh, I'm confused. Okay, no, I think the genetic solver is just doing what we expect it to do. It's just doing a red, green, blue sort. But it's doing it faster than we might otherwise hope. So is that even useful for us? A red, green, blue sort. I mean, I guess it is. Sure. Red. But we still have to sift out stuff, don't we? Do we get a load balancer? We do get a load balancer. Let's put a load balancer at the front of this. And then use 2 of these. So this at least gives us red, green, blue, and then we've got to use, I guess, chained sifters? Or do we have a custom shaped... We do have a shape divide. Ugh, that is a... Why does it have 4 outputs? Shape divide has 4 outputs? Why? 2 parallel, 4 parallel. Shape divide. Where does this come from? Can I double click this? No. Let's see if we can find that in our prior jobs. Can I look at my prior jobs, please? Well, let's accept this job quick, and then we'll go back and look at the shape divide thing. It's fine. Okay, it says it's auto-saved. Let's try and find our shape divide. There's shape divide. What are the outputs here? Oh. Well, that shape... Okay, so that shape divide is not something that is helpful for... Wait, actually, maybe it is. The 4th output is only triangles. Okay, so the bottom is only triangles. The middle is all shapes, and the top is circles and squares. Is that even remotely useful? All triangles. That sounds nice. Shape divide is going to give us all triangles. Both of these were all shapes, and this was only circles and squares. No, I don't think that's helpful at all. And it requires 6 servers. Pass. Okay, never mind. Pre-change genetic algorithm. I wish that we had like an RGB sort for shapes, because that would be a nice thing to have right about now. All right, well, let's copy this. So we get these pre-trained genetics, and this is doing RGB sorts. Okay. So everything, let's figure out a red path, a green path, and a blue path. We need to filter all of these shapes, which is going to require a lot of sifting. So if it's red, if it's a circle, it goes here. If it's not, then if it's a square, it goes here. If it's a square, it goes to trash. Otherwise, it can go, well, either of these places. But I don't particularly care where. And we don't need to worry about getting the right amount to one or the other. Okay. Fair. So these are hooked up. So that's the red path. And we'll have I guess a whole duplicate of that chain down here. Yeah, let's pull this back. Let's pull these both back. So red, filtering out Oh, you know what? Actually, we should do that in reverse order. Let's get rid of the trash first so that we don't have to spend time sorting out more stuff. This can go into the trash. Yeah, so red squares are trash, and then red circles have to go here. Otherwise, it's a red triangle, and it can go here. I mean, it could go here too, but whatever. And then I guess we can copy and paste these. Put them down here as the red path for this. If it's a square, it goes to the trash. Sorry, no, square goes to the trash. Otherwise, if it's a circle, it has to go up here. Oof, this is going to get messy. Otherwise, it's a triangle, and that can go down there. That's fine. Okay. Now, the green path. Oof, gosh, this feels wrong. This feels like we're doing something dumb that we shouldn't be doing, and the genetic algorithm ought to work on multiple things. I don't know. Okay. So green. If you're green, what are we doing with you? If you're a circle, then you're trash. And if not, then we do need to sort you. Okay. So if you're a square, then you can go here. Otherwise, you have to go down with the triangles. And same thing, we'll copy paste that down here. Oh no, no, undo. Oh, I don't get an undo. Oh God, what did what have I done? This is getting worse and worse. Okay. If you're green, if you're a circle, you're trash. If you're a square, you can go here. Otherwise, you can go here. What is this trash can doing? That's fine. Okay. I'm not going to do the copy and paste because I don't maintain the selection. So whatever. We'll pull these up here. This is our red path for down there. Let's create our green path for down there. If you're that, you're trash. I'm creating duplicate trash cans, but I don't care. If you are a square, what is this SIF doing? Okay. If you're a square, you can go here. Otherwise, you go there. Yeah, so we don't spend time sorting trash. Nice. I think that's helpful. Yeah, it should mean that there's less data getting into here to be sorted, whereas if we were doing that, then everything. Okay. The earlier we can get rid of data, the better. Okay, so now the blue path. If you're blue, okay, so blue, we filter out squares first. Squares go to trash. Everything else has to be sorted. Ugh, this is gross. All right. Blue circles go here. Blue triangles go, well, that one can go up there. That's fine. And if you were a blue square, you're going to the trash. Otherwise, we're going to sort you according to shape. If you are a circle, you can go here. Otherwise, you're a triangle, so go here. Let's try that. Oh, we don't even need to be accurate. Well, that's annoying. We only need to be 80% accurate. But okay, we're accurate. Or at least close enough to pretend we're accurate. And I'm gonna call that good. Let's go ahead and release it. I mean, it feels slow, but a lot of these were feeling slow, and there's no real good way for us to know whether we are actually slow. The blood center apparently is slow. I mean, just based on our weekly income, I guess. All right. I think we'll go ahead and call it there. We've got 4 startups now. We're going to have to, I guess, sell one of them at some point. We're overloaded on some of this stuff. Our shares do not seem to be going up in value, which is kind of a bummer. But hey, what are you going to do? Oh, we're actually close to the end of the week. So hopefully, if we do one more task, we should say that. In fact, let's try and do that real quick. Okay, genetic solver. Okay. Is this okay? So blues have to go here. Greens have to go here. We're getting paid enough to do a load balancer, so we can just do that, I guess. Except we've already got a pre-trained genetic algorithm. It does seem weird to have these. What was it? Oh yeah, no. But if we're doing this, we should do it the other way. Load balance at the front. Load balance at the front. Because we're not paying any additional cost to have 2 genetic algorithms in here. So, okay. Red can go up there. Red can go up there. Green can go up here. Green can go here. This should be faster than doing it the other way. In theory. Let's check. Actually, we don't need to train. Why is that one slow? Whatever. Okay, release that. It's gonna cost some money. That's fine. Okay, success. And yeah, happy with that. Okay, so let's see. Can I get my weekly income, please? I'm excited to see this go. Okay, self-driving car. We made $5,500. We spent $27,000. Cool. Here, from Gamazon, we made $20,000. Spent $2,500. So we have made a lot of money there. The blood center, not much money, and the evolver, poof, that's gross. All right, well, fair enough. We'll have to take a look at what we do next week or next time. I don't know, some other time when we look at this stuff. I guess we have to sell something off if we're gonna look at another. Oh, we don't even have enough money though to do that. Why don't we have enough money? We just made a whole bunch of money. Oh no, this is our share. Oh, this is the. Yeah, this is the company balance. Our share isn't that high. Okay, well that's kind of a bummer. Oh well. Yeah, but this game is this is fun. The startup stuff is getting interesting. We'll have to see what we do next time, and I will see you then. Cheers.